said in the last video, we're going to work through finding the derivative of cosh inverse. I'm actually going to have you folks do that on your own in just a moment. But I've reminded you here, this is what the graph of y equals cosh x looks like. And it's not invertible. It fails the horizontal line test. So we do need to restrict the domain to get an invertible function. And we do that, we just choose the right half of the graph. So this is y equals cosh x with x bigger than or equal to 0. This is the function we're going to be taking the inverse of. When we do that, we get y equals cosh inverse of x. I've drawn the graph of it here. I'm not expecting you to know to be familiar with that graph, but kind of nice to see it. Okay. And what this means is that x is cosh y, and that restriction becomes a restriction on y. Y is bigger than or equal to 0. So what I want you to do is use that equation, x equals cosh y, use implicit differentiation to find me a formula for the derivative of inverse hyperbolic cosh. Now, as you do that, when you're trying to get things in terms of x rather than y, you're going to need to use your hyperbolic trig identity. You're going to have to take a square root. You're going to have to decide whether to choose the positive or the negative root. You're going to need to use the fact that you know that y is bigger than or equal to 0. Okay, so it's a little bit trickier than the last one was, I think, but see if you can figure that out and then tune back in and we'll work through it together. I've written out most of the work for this problem here. This part should feel pretty familiar. We've done this a lot with regular trig, and it's not that different with the hyperbolic trig. Okay. So we start with x equals cosh y. We take the derivative with respect to x of both sides. We get 1 equals sinh y prime. Solving for y prime, we get the reciprocal of sinh y. We'd like to replace that sinh y with an expression involving cosh y so that we can replace it with x. So we rely on our hyperbolic trig identity. Cosh squared y minus sinh squared y is 1. Now I just added the sinh squared y over to this side and then subtracted the 1 over. So we've got cosh squared y minus 1 equals sinh squared y. We take the square root of both sides, and of course the square root of sinh squared is the absolute value of sinh y. Now, when we had the absolute value of cosh y, we knew cosh y was always positive, so we were able to just say that absolute value evaluates to cosh y. Here, it's going to sometimes be sinh y and sometimes the opposite of sinh y, so sinh of y is either plus or minus the square root of cosh squared y minus 1. And of course, it's not both. It's not that we get to pick one at random. When sinh y is positive, we'll choose the positive root, and when sinh y is negative, we'll choose the negative root. This is where we need to use this restriction. We know that y is bigger than or equal to 0. So I know that the input to sinh is non-negative here. And if you remember, the graph of sinh looks something like so. So it lies entirely in quadrants 1 and 3. And when we looked at this for the first time, I pointed out that what that means is that sinh of something positive, this is very informal notation, is going to be positive, and sinh of something negative is going to be negative. The plus or minus sign of the output matches the plus or minus sign of the input. Okay. So, because I know that y is not negative, I know that sinh of y is not negative. So here, I need to justify that. Every time you make a choice about whether it's the plus or minus route that you're taking, I want to see an explanation. Okay. This is going to say that sinh of y is bigger than or equal to 0 because y is bigger than or equal to 0. Okay, so with that, let's see, I'll just come back over here. Y prime was 1 over sinh y. I can now say that's 1 over the positive square root of cos squared y, which is cos of y squared minus 1, but cos of y for this problem was x. So that's 1 over the positive square root of x squared minus 1. Okay, good stuff. I would recommend that you practice deriving the derivatives of the other 4 inverse hyperbolic trig functions. Again, you are not responsible for having those results memorized, simply for being able to derive those results. And I'll remind you that with tanh and cotanh and cosech, those are all invertible with no restrictions. With sech, to make it invertible, you have to do the same thing that we do with cosh, restrict it so that x is bigger than or equal to 0.